Okay, this week we will finish this chapter. The first topic is DHCP. But before we continue DHCP, we would like to introduce some other materials that is not in the textbook. So please follow me. I will draw something about IP address, IP spectrum, and explain some concept of how to design IP and how IP is classified. So this is not in our textbook, but I think it is very important for you to understand those concepts, and it's very helpful to for you to understand all the following DHCP and IP addresses. Okay, so let's take a look at the left hand side. Okay, we have a Wikipedia code. Is a classical network. Okay, as we mentioned before, currently we use IPv4 version 4 as our major IP protocol, right? And IPv4 has 32 bits to represent an IP. So in this case, in total we have around that much IP addresses. It is almost 4 billion of IP addresses can be defined in IPv4. And for those IP addresses, actually not every IP address is they have different classes. So I would like to draw something like this. Okay, and I think it's okay. So let's see. It is the entire IP address space. Okay, so the very first one. Okay, the very first one should be an IP address that OS bits are 0, right? So something like that. Okay, and we have 32 bits zeros, and it is very difficult for human beings to remember such IP address. So we have another representation, right? 0.0.0.0, right? That is the very first IP address in the IP spectrum. And similarly, the last IP address should be all bits with ones, right? Right, and we have a lot of ones right here, and at last we have all ones in these 32 bits field, right? So its corresponding decimal IP address should be that is the last IP address can be defined in the IPv4. Okay, and for the first beginning, okay, the organization that manage the IP address is ICANN. Okay, ICANN, and of course there are a lot of universities in the United States and the military organization. They try to obtain IP address from the ICANN organization because it manages. They manage how different IP addresses can be distributed to different organizations. So at that time, they have a table like this. We call it classical addressing definition. So basically, in this entire 4 billion IP addresses, we have several different classes. For example, right here. Okay. So let's take a look at the first row, class A. So half of the IP address. So we draw a line right here. Okay. So since it is the half, so this line divided IP address spectrum into two different halves, right? So the boundary right here should be an IP address that starts with 0 and all the rest of 31 bits are all ones, right? Something like that. Okay, there should be an IP address right here, and it is the boundary of it is the boundary of the top half and the bottom half. And the next IP address, it should be the IP address starts with 1 and all the rest of 31 bits are all zeros. Right? So that is a half of the IP address, and it is the boundary. And the corresponding decimal representation should be okay. So half that address, the boundary is like this. So you can see that the very first, the top half, okay, all the IP address, only top half, they are all starts with 0. So that we call the leading bit or the significant bit of this IP, the top half IP address. They start with 0. Okay, so in the definition of classical IP network, okay, we call it class A. So let's take a look at the left-hand side and the first row. It says for the IP addresses in class A, their leading bits are all 1 bit 0, right? So that is the top half. And we define all the IP addresses in the class A. The size of a network number, we mentioned it before, we can divide the IP addresses into 2 different parts. Left-hand side part, that is the network part, or called network ID, right? So in human beings, we define, okay, we define in class A, all the IP address is network part is a bit, and its host part, or say its host ID, okay, is 24 bits. Okay, we define all the IP address in class A. Okay, network part has 8 bits and host part has 24 bits. Okay, so in this case, we can divide these IP addresses based on unique network part. So as we mentioned before, each network part, they should be unique, and each network part can be assigned to a subnet. So in this case, we can divide the entire class A spectrum into several different subnet. Okay, into 7 different. But how many subnet it can be? So it is defined by how many different network part, how many different unique network ID are there in class A. And we can see that there should be 8 bit length, 8 bit long, right? So theoretically, it should be 2 power 8, right? But think about one thing. All the IP addresses in class A, their leading bits are 1 single bit 0, right? So this first bit, this leading bit, is the same for all the IP addresses in class A, right? So basically, you have only 7 bits that can uniquely differentiate different subnet in class A. So in total, we say total, we have 2 power 7. That is 128 subnet, unique subnets in class A, in the range of class A. Right? We can easily understand that by taking a look at the decimal IP address. Right? The very first IP address starts with 0, and the last address starts with 127, right? So there should be 128 unique subnet network ports within class A. Although we have 8 bits can be used to represent network port, but the very first bit are all the same in classes A, so we have only 7 bits that can uniquely identify different subnet port. So in total we have 128 unique subnet ID, right? So in this case, so at the right hand side we have 24 bit to represent host, right? 24. So each subnet has 2 power 24. That is around, let's take a look at this table. Okay, this table, that's around 167772216. That is 16 million unique IP address can be represented in a single subnet in class A. Okay, so in total, in class in class A, okay, in the range of class A, okay, maybe we should draw the figure more precisely. So they should be right here. Okay, in the entire class A, okay, according to the network part, okay, we have 7 bit can uniquely identify 126 up to 128 different network part. So we have 128 unique subnet in class A, and for each subnet in the class A, okay, we have 24 bit. So total, for each subnet we have 16 million IP address in a single subnet in class A. Okay, so let's take a look at this this one. So class A, the leading bit is 0, right? The network size number is 8. Okay, the size of rest bit field, which means the IP host part, is 24 bits. So in this case, we have 128 subnet, unique subnet. Okay, so the IP address per network is 16 million IP addresses. Okay, so in total, we have, it's around 2 billion IP address in class A. It is a lot of IP address, and the starting address is 0.0.0.0, and the end address is 127 to 55 to 55 and 255. Okay, so in this case, because all those subnet, they use 8 bit as their network part, so we say that is a /8 CIDR, right? The CIDR notation is /8. Okay, let's take a look at the next class. Okay, take a look at the next class. So for the next class, okay, some researchers, okay, they manually defined, okay, we divide the rest of the IP address into 2 parts, okay, and each part, so it starts from 101, right? So again, this IP address, the boundary should be 101. The next one should be okay, because we divided the button half to two parts again. Okay, so in this case, we can see that the leading bit in this part are all 1, 0. So we call this class B, and they start from this address to this address. Alright, okay, so let's look at the second row. The leading bit for class B is 1, 0, and we manually define, okay, in class B, okay, we define the network part, okay, network ID is 16 bits, and the host ID has 16 bits as well. Okay, so let's take a look at this one. Okay, so again, we can divide class B into 7 different unique subnet. Okay, and as we can see that the network part in class B, we human, okay, we identify it should be 16-bit, but however the first 2 bits are all the same in class B, right? That is, its leading bit is 1, 0, so we have only 16 bits can be used to represent the network part uniquely. So total we have 2 power 16, and let's take a look at 14. Although we have 16 bits to represent network part, but only 14 bits are unique, can be uniquely represent a number. Okay, so that is around 16,000 subnet. Okay, so there should be 16,000 blue blocks in class B, in the region of class B, and for each subnet in class B, okay, it has, okay, let's take a look at the right hand side. Okay, in class B we have 16 bits to represent the host ID. So in each blue blocks, it contains 65,000 unique IP addresses in single blue block in class B. Okay, so take a look at the second row. Okay, we have 16,000 of subnet. Okay, and for each subnet we have 65,000 IP address, okay, unique IP address in each blue block. Okay, so total we have that much. It should be 1 billion IP addresses. So we can see that the first IP address in block in class B is 128.0.0.0, right? So the last IP address right here, it should be 191. The next one is this. So all IP address in class B, they have same leading bit, 2 bits is 1, 0, and the next 14 bits are used as the unique part for network ID, and the rest of the 16 bits are host ID. Okay, so that is, and in this cases, this CIDR representation is 16 because we have first 16 bit are used as the network ID. right? So it's /16. So on and so forth. So again, we divide the rest of the IP address into two parts, and we use another color. So we called it class C. And again, there should be a boundary right here. So let's take a look at this one. The last IP address of class C should be 110. The next one should be 10. Okay, so for this class C, okay, again, we manually define that the net part is 24-bit, and the host part has 8-bit. And we can see that the leading bit right here, they are all 110. So let's take a look at the third row. For class C, the leading bit is 110, and the size of the network, the first network part is 24-bit, and the rest of the part is the host ID. It is 8-bit. Okay, so again, we can, according to the network part, okay, right here, in total, right, we have, again, we have 24-bit can be used as the network part, but the first 3-bit is the same, right? So we have only unique that much. So that is 2 million. We can divide this part of IP address into 2 million different subnet, okay? And for each one, okay, so for each green subnet right here, it has, since we have 8-bit, right, used to represent host ID in the subnet, so we have only 126 IP addresses in each green block. So let's take a look at left hand side. Okay, the number of network is about 2 million, and for each network, each subnet in the green subnet in class C, okay, it can only contain 256 IP addresses. So in total, we have that much IP address in class C. Okay, so the starting address is 192.0.0.0. So the last one should be this one. And again, because we use the 24-bit as the network part, so we write it as /24. So that's it. Okay, class D and E are not used actually in the real world, so we only introduce class A and B and C, and that is how we divide the entire IP spectrum into different classes A, B, and C. Okay, that is because when they distributed those IP addresses to different ISPs, to different university, to different military service in the early days, they simply just give one single subnet to that organization. For example, in NCCU, okay, in early days, we gather a class B IP address from the authority, from the organization. The authority is ICANN, but it has several different sub organization in America, in Asia Pacific, in Europe, and in Taiwan we have TWNIC as the authorized organized, which can distribute those IP address different subnet to different universities, military organization, and ISPs, and NCCU get one of the block. So in early days they use different classes, okay, to divide the entire IP spectrum into different subclass, subnet, and distribute those subnet, those IPs, okay, and submit to different organizations. Okay, so that is one of the things you need to know. Okay, and there's some other things. Okay, so let's take a look at this. The other Wikipedia, we call it private IP address. Okay, although we have almost 4 billion IP address can be used in IPv4, but however, I think in 2011, ICANN had already given all its IP address to different organizations. So currently, we don't have any IP address can be used for new organizations. All those IP address has been used by some organizations. But when they design the IP address, okay, there are several IP addresses that are defined as private IP addresses. Okay, right here. So we have a table right here. So we have 3 different blocks. Okay, so let's first take a look at the first one. Okay, the first row, it writes, we have an IP address right here. So 10.0.0.0, right, to 10.255.255.255. So it's probably right here. Okay, some IP address block right here. Okay, so it starts from 10. Okay. As we mentioned before, in Class A, there are total 128 subnet, okay, in Class A. But one of the subnet which starts with 10, okay, 10.0.0.0 to 10.255.255.255. So as we mentioned before, right here, okay, in each block or in each subnet in Class A, it has almost 16 million IP address. Okay, so in IP address, okay, let's define a range right here. Okay, it is a one single Class A subnet start with 10. Okay, this amount of IP address has never been distributed to any organization. It is preserved for special usage. Okay, so the first row, okay, we have a /22 we have a /8 IP address start with 10. Okay, it has 16 million IP addresses. Okay, and its CIDR is 10.0.0.0/8, right? So the mask is 255.0.0.0. Okay, the host ID size is 24, the mask ID is 8. Okay, we have a single Class A network has been preserved for special usage. So no one can use these IP addresses in the internet. Okay, so that is one of the private IP address block. Okay, and the second part is start with 172, right? So 172 should be somewhere right here, right? Somewhere right here. Okay, so it starts with okay, so the next one is sorry, it's 172. That's the second row, huh? Okay, so there should be several different Class B subnets. Okay, so the first one is 172 192.16. Okay, so in this case we have about 65,000 IP address in this class B, right? So right here we have 16 class B subnets. Okay, we have 16 class B subnet. So the address in this area is about 1 million. Okay, it's subnet. It has several class B subnet, right? So okay, that's good enough. Several class B that is not used, is not distributed to any organization in the first place. Okay, and the third part is 192, right? So 192 is probably right here. Okay, it's probably right here. So as you can see that we have 256 class B subnets. Those subnets had been preserved for private use. So no any IP address in these 3 different blocks can be used on the internet. Okay, we will talk about how those IP addresses will be used in your LAN. Okay, we'll talk about it later. Okay, so that is okay. So I think that is some of the important IP addresses you should know about before you study another IP these topics. Okay, and there are some spatial IP addresses, okay, in this spectrum. Okay, again, this one 0.0.0.0, because it is an IP address that all bits are 0, right? So it is very special IP address. You should not use this IP address because this IP address indicate unknown IP address. So if you are inferring or you are indicating some IP address that you don't know your IP address, or you don't know your destination IP address, something like that. If there's some IP address you want to indicate that you don't know, you can simply use 0.0.0.0, because that means an IP address that I don't know. Okay, and here we have a very special IP address right here. Is this one. This specific IP address, that means local host. That means this IP address infer or indicate myself. That means I don't know what is my IP address, but I don't know. I don't care. I can simply use 127.0.0.1 to represent myself. Okay, so we use another word, local host. So it represents local host. It really doesn't matter what IP address actually you use, but you would like to indicating the IP address used by yourself. You can use this IP address 127.0.0.1. Okay, and again, this one, that's the IP address, that is broadcast. Okay, that means you don't know your destination IP address. You want to send something to in your network, but you don't know what exactly the IP address used by your destination IP address. You can simply use 255.255.255.255. That means I simply just broadcast this IP diagram to all of the hosts who can receive your signal in your LAN, in your subnet. So all the network interface card in your subnet can hear, can accept, can receive your IP diagram. Okay, if you use 255.255.255.255, you use the broadcast IP address. Okay, so I think that is the structure of the IP address you should know. Okay, we have class A, class B, class C. We have several different regions which is used as the private IP address. Okay, we have those orange IP address are defined as private IP address. So all the other addresses are defined as public IP address. Okay, and those orange ones, they are private IP address. And we have some spatial IP address. Okay, 0.0, the 0.0 is unknown, 127.0.0.1 is localhost, and 4.255 is broadcast IP address. Okay, I think that is you have to remember all of the things because we use these IP address in the later classes. Okay, so let's go back to DHCP. Okay, so again, let's take a look at the DHCP. Okay, so it is a situation that when you arrive a new subnet, okay, and basically you don't have an IP address, right? And you don't know what is the DNS, what is the IP of the DNS server, what is the IP of your first router. You don't know the subnet mask. You don't know all the things. You simply just bring your computer, your notebook to the classroom, and you simply just connect your laptop to the campus network. But how your laptop get an IP address from your campus network? There should be some mechanism, right? The mechanism is called DHCP, Dynamic Host Configuration Protocol. This is a layer 7 protocol. Okay, it runs on the top of UDP. So let's take a look at the definition of DHCP. So the goal is the host to dynamically obtain IP address from the network server when it joins the network. Okay, it can renew its list on address in use. Okay, allow reuse of IP addresses. Okay, support for mobile user who join the live network. So basically, the DHCP has 4 packets. Okay, right here, DHCP discover, DHCP offer, DHCP request, DHCP act. So by using these 4 UDP packet, a new mobile user can obtain IP address from DHCP server. So let's take a look at this view graph. Okay, so for example, right here we have a subnet, right here. Okay, we have a DHCP server right here. We have a router, as we mentioned before. The border of the subnet should be a router, right? And we have several different hosts in this subnet. Okay, if you are a new arriving this subnet, basically you don't know what is the subnet, what is the host part, what is the IP address you should use. You don't know the DNS server. You don't know anything, right? So how did you get those information from the subnet? Okay, so basically let's take a look at this one. So basically, okay, the arriving client, it should run a DHCP client. Okay, it is a layer 7 program. Okay, it runs on the UDP, on the top of UDP. Okay, so the arriving client will broadcast a packet. Okay, a layer 7 packet. Okay, is there a DHCP server out there? Okay, as we mentioned before, since you are a new arriving client, you should not have any IP address, and you don't know whether there is a DHCP server in this subnet. So basically, the strategy is that you use 0.0.0.0 as your source IP address and use broadcast as your destination IP address to construct this specific IP datagram. So this IP datagram has an IP address, has a source IP address, has a destination IP address, but they are both a very strange IP address. 0.0.0, that means I don't know what is my IP address because I'm a newcomer, I'm a arriving client. I don't know what is my IP address or what it should be. And I don't know what is the DHCP server. I don't know what is the IP of the DHCP server. So I use broadcast IP address. So in this subnet, for example, in this subnet, okay, if such packet has been sent by the arriving DHCP client, okay, as we mentioned before, all the network interface card in this subnet can receive the DHCP packet because it is a broadcast. Okay, so all the network card in this subnet can receive such IP diagram, and they will again, okay, receive the packet to layer 1, to layer 2, to layer 3, to layer 4, and to layer 7. As I mentioned before, DHCP is a layer 7 protocol. Okay, but it depends on if there's any DHCP server program listen at DHCP UDP port socket. Okay, for example, this specific IP diagram will be received by all of the network interface card. Right there, we have 5 network interface card right here, right? But only the DHCP server will send this specific segment, this specific message to the corresponding DHCP server program, and the rest of the 4 other hosts, because they do not run DHCP server programs. They did not open any corresponding socket, so therefore this packet will be dropped. Right? Only the DHCP server program open the socket and listen to the socket, so the operating system can send this specific DHCP message to layer 7 of the DHCP server. Okay, so after that, the DHCP server is right here, okay, right here, say broadcast. Again, because the arriving client has no IP address right now, so the DHCP server can only do broadcasting. Okay, so it says I'm a DHCP server, here's an IP address you can use. So again, okay, the destination IP address is still a broadcast address. Okay, so again, every network interface card in the subnet can receive such broadcast from the DHCP server. Okay, this packet is called DHCP offer, and there are some information in the layer 7 message. So after that, the arriving client right here, it received the corresponding DHCP offer, so it can choose one of the IP addresses provided by the DHCP server. And again, do the broadcast, say, okay, I would like to use one of the IP address. And again, that's the one is a broadcast again. Okay, you have got that IP address. So basically, the client and server can use broadcast mechanism to exchange messages, even if the arriving client has no IP address, and the arriving host does not know what exactly the IP address is used by the DHCP server. But by using the broadcast mechanism, they can exchange messages to obtain the information about what kind of IP address provided by the server, what is IP address used by the DHCP client, and what is so on and so forth. A lot of the information can be exchanged in the DHCP request and DHCP ACK. Okay, and I have to mention one thing is that the DHCP discovery and the first and the second packet, DHCP discovery and DHCP offer, is optional. So basically, even if you only have DHCP request message and DHCP ACK message, it is okay for the DHCP client to obtain an IP address and the corresponding information about the subnet. Okay. So let's take so we can simply just skip this one. You can take a look at this one, okay, by yourself. Okay, let's take a look at the Wireshark output. Okay, so simply we have a DHCP request and DHCP reply message in this page. Okay, so so that is a layer 7 message. Okay, and you can see the left hand side is the DHCP request broadcasted by the DHCP client. So it says the message is a boot request. So that means I would like to obtain an IP address from the server. Okay, so again, right here we have a transaction ID which is 6B3A11B7. That is a unique ID randomly generated by the DHCP client. So that the server has to use the same transaction ID to do the reply at the right hand side. Okay, we can see that that is the server to client, right? That is the client to server, right? So in this case, since the client has no IP address, so we simply just use 0 IP address right here. That means I don't know what is the IP address I use. Okay, and again right here, okay, I would like to do a DHCP request. Okay, so if possible, please tell me right here, okay, the option, please tell me what is the subnet mask used in this subnet, what is the DNS domain name used in this subnet, what is the first router, what is the edge router in this subnet, and what is the domain name server, local DNS server used in this subnet, and so on and so forth. You can ask a lot of different optional questions. If the server knows answers, at the right hand side, when the server reply, again use broadcast. Okay, so it is a broadcast message, and its message type is boot. It's reply. Okay, and the server should use exactly the same transaction ID, so that client knows that is the response to its question. Okay, so right here, okay, that means the client IP address, it can use 192.168.1.101 to use it as the IP address. Okay, so that is the IP address given by the server. Okay, so the next server IP address right here, that is the first router. That means if you would like to communicate with the router, you can use 192.168.1.1. Okay, so here we have a lot of answers right here. For example, the server uses this IP address, and the subnet mask is /24, right? And the first router, the edge router, is this IP address, and the corresponding domain name server, the DHCP server had provide 3 IP address as the domain name servers. Okay, and the domain is right here. Used in this subnet is right here. Okay. I would like to show you something about real world packet. So let's take a look at this one. Okay, so again, okay, we have Wireshark right here. So let's take a look at this one. Again, right, we have 4 different packets. It's called DHCP discover, offer, request, and ACK. And as we mentioned, discover and offer is not necessary. Okay, it is okay if you have only request packet and the ACK packet. Okay, it contains enough information for the DHCP client to obtain a packet. Okay, but we still take a look at this one. Okay, that is DHCP discover, and we can take a look at the IP diagram. Okay, we mentioned it before, but we have never show you in Wireshark, right? So here is the IP headers. Okay, the first 4 bit is the version number. We mentioned it before, right? So it should be 1000. it indicates decimal number 4, right? That means we use IPv4. Okay, the second part is the header length. Okay, this number is 5. That means we have 5 words, and each word is 32-bit, right? So in total, if this number is 5, that means we have 20 bytes header. So we have no option. Okay, so this one is TLS, right? So we simply just use all zeros because currently we don't use this field because the routers will not help you to do TLS service. Okay, and next part is the total length. That is the entire segment, entire datagram size. So it's 300 bytes. Okay, so we have 20 bytes header length. We have in total 300 bytes datagram. So again, we have 280 bytes for the layer 4 segment, right? So it is a random number. Okay, it is the identification number right here, and these three, okay, identification number, the fragmentation flags, and the fragmentation offset. Basically, but currently, we simply just set our MTBU size to 150, and all routers do so. So basically, we don't need to do fragmentation in current internet. Okay, basically, okay. So we simply just use 0, 0, 0, and 0 right here. Okay, we talk about time to delay. It is the limit how many hops you can hop to the next routers when you route your packet from the source IP address to the destination IP address. And for some operating system, it could be 256, can be 128, could be 64. Okay, it depends on you believe how many different what is the maximum hops you can reach to your destination. Okay, but this number is 250 in this case. Okay, so since we would like to demonstrate the DHCP, so it is UDP protocol. UDP is 17, TCP is 6, and ICMP is 1. These 3 numbers you should remember. Okay, that is a header checksum. And here, as we mentioned before, for DHCP client, because you don't know what is your IP address, so basically you simply just put 0.0.0.0 in your DHCP discover and DHCP request message. Okay, and because you don't know your DHCP, what is the IP of your DHCP server, so you simply just use a broadcast IP address right here. So every host in the same subnet should receive this specific DHCP discover packet. Okay, so that is DHCP, and then that is the UDP. Okay, the destination port of UDP is 67, and again, that is the DHCP message. There are several messages in the DHCP discover. As we mentioned before, you have a message type and you have a transaction ID right here. So in this, it's 3D1D. Okay, and again, you don't have IP address, so you simply just put 0 IP address right here, and there are some options you can ask. Okay, I would like to know some parameter right here. I would like to know the subnet. I would like to know the routers. I would like to know the domain name servers, and I'd like to know if there's any network time protocol server in this subnet. Okay, a lot of protocols. There are a lot of options right here. So the offers again right here. Okay, in this example, you can see that the IP address right here is not, as I mentioned before, it's not a broadcast message right here. It is a unicast. Unicast means we have a specific IP address and a specific destination IP address. That is because this example is because, okay, let's take a look at this one. When you do right here, when you take a look at your IP setting in your no matter in your smartphone or your tablet, in your laptop, okay, you can always see there is a very specific button right here. Okay, of course it is traditional Mandarin, Chinese, but this button means to renew your DHCP list. That means when I push this button, this specific button, my DHCP client in my operating system will send all this discover or request the message out and try to seek in if there's any DHCP server in my subnet and try to get a new IP address from the DHCP server. So that is how this button works. Trying to renew your IP address. Try to renew your DHCP lease. Okay, and I think this this 4 packet is captured by someone. Okay, because I download this DHCP packet from the internet. Okay, I think that is because when the person who record all these 4 packet, maybe he or she simply just push the button. So it's DHCP client will send this one out and receive this packet, send this one out and receive this packet. Okay, but at that moment, this DHCP client, this for example, this laptop or this PC already has an IP address. It is not a new arriving client. I think it simply just renew its lease, its IP lease. Okay, so I think that is the reason why the server simply just use a unicast, which means use a specific IP address and send to this specific destination. It does the DHCP server does not use broadcast to send this message, because I believe when they capture this 4 packet, they simply just renew the packet. It is not a new arriving host in subnet. Okay, but the message inside is very similar. Okay, we still would like to know what is the subnet, what is the renew time, what is the IP address list time. Okay, the IP address list time means and this before this time, okay, usually it's in second. Okay, before this 306 seconds, you can use the IP address that the server sent to the DHCP client. But after 1 hour, for example, right here, after 1 hour, you have to send another DHCP request a packet to the server to get a new list. Okay, so it can be set in the DHCP server. Okay, so again, the third one is the request. So the request is right here. So it said, okay, you can use this IP address 192.168.0.10, and the last packet is again, okay, it confirmed, okay, I will use this 192.168.0.10, this IP packet. Okay, and we have some a lot of information right here. We have the list time, we have the DHCP server IP, we have the subnet mask, and so on and so forth. Okay, I think that is a very interesting things that you can take a look. So if possible, please try to capture the DHCP packet in your home network. Okay, you simply just open your Wireshark and capture the packet. Okay, and you can simply just push the button. For example, push the IP address renew button. This button, you can find this button in Windows and Mac. Okay, operating system provides such kind of functionality. Okay, after you push this button, you can simply see that you can capture this 4 packet or this 2 packet to obtain a new IP addresses in your operating system. Okay, I think that is okay. That is DHCP. Okay, we stop right here.